And now, increasingly digital world, we have constantly some protocols, interfaces emerging. Majority comes and goes and nothing really stays over time. So USB established itself as one of those interfaces that remained over time. USB, with all its advantages and disadvantages, has been challenged to implement, which we did. IVDT is an outcome, is a creation of all these modern technologies that organize the data of music. The advantage of a VDT is basically one can use the solid-state hard drives, USB and all other things. So one can use the VDT with another DAC and gain an improvement in the musical performance and an analog character of that system. We designed our VDT very differently than majority of the low-cost computer manufacturers there. The computers that one tries to pair with the DAC, they are consumer grade. They're made with lower cost, mass consumer sort of low-cost materials and components. They're optimized for processing power, for the processing performance, not musical performance. It is not making your system to sound more like music. The streamer is equally as important as the DAC. And then there are a lot of companies that present that these streamers are purposefully made for audio without even understanding what makes these things to sound like audio devices. You look inside and the materials used in there, power supplies and everything around there, they're not much different from a normal sort of consumer grade computers. One basically repackages into something more fancy, puts a higher price tag, and then offers it to the public and says, well, it's audio grade. It's still a consumer grade product packaged differently. Yeah, we found a couple of fancy power supplies, a couple of, sort of toroidal transformers in there. Okay, audio grade capacitor, that's the only thing. The rest is still very much consumer grade. The VDT is a different approach. It is a radical departure from this normal consumer grade type of products. Once connects it to any sort of a DAC, even divorced ones, one notices the difference and the gain in musical performance. Music is a language of emotions, not language, a code of for robots and transmitted between robots. If one starts thinking about a system as a living organism, one has a totally different approach, how one designs everything. Since an audio system is an organism, we need to think in terms from a biological point of view. It's an independent functioning being, right? And it consists of different organs. Organs, they're all intertwined and they will talk to each other and communicate in an optimal way, in a harmonic sense. If that doesn't happen and the organism doesn't live for too long, it dies. That's the source of all the diseases. USB is a computer interface. We constantly use some sort of donors. The computer is made by somebody else. So, okay, they understand each other, the USB interface and the computer. Otherwise, it wouldn't work. But it's about transferring the data in a certain fashion that is presented as music. So that's a different thing. So the first problem that we already highlighted here, if it was an organism, then we have constantly some sort of donor organ. We have one organ, USB interface, and then we have interconnect made by somebody else, and then we have another organ made by somebody else, and they're supposed to sing in unison and harmony and produce music. We are very sparing with this USB interface, and therefore we leave the USB to only entry-level products. It's about versatility. It's not about getting maximum performance, though we're looking to maximize the performance, but we reduce the USB to entry-level products. It's not the only reason. The USB, if it's designed correctly, it's not just a small USB socket, a PCB with a couple of SMD components on it. That's not what USB is. This is a cheap device you can buy online and it will cost you a couple of dollars, okay? This is not what we sort of want to put inside our DACs. But you'll be surprised, the vast majority of DACs comes exactly with that sort of solution. There's a USB socket and a small USB sort of processor receiver with a small sort of clock, a couple of power supply capacitors, and that's more or less it. That's your USB interface. Sorry, that's not how I would like to have the USB interface made inside our DACs. Some manufacturers think, okay, it needs to be powered, so it works in asynchronous fashion, so it's not relying on the source, and it has its own 5-volt power supply, okay, that's a good step into the right direction. But that's not enough. In order the USB to function above mediocre average level, the USB interface itself is not just a USB socket and a processor, a receiver. It's not just some sort of asynchronous clock. No, it's way more than that. So the clock itself is a noisy device, so it requires its own transformer. Now the rest of the USB processor doesn't want to get all this noise, so you need to keep it separately. So it requires ideally another transformer. Now the clock is not just a small little quartz, right? It needs a proper circuit around it. One needs to match the impedance, one needs to generate proper signal of the correct waveform, and it just can't be a small little quartz, you know, with the metal casing. In order to get a USB device and interface inside the DAC, ideally for audio purposes, I'm talking about audio purposes, it needs to at least to have one separate transformer with multiple separate secondary windings. So that's already by definition bulky, heavy. Now the USB interface itself needs to be properly designed. We want to use the best possible materials. SMD materials that is being used inside those SMD components is the lowest grade. It's the miniaturized stuff. We want to have full-size through-hole capacitors. We want to have the best sounding materials on, and that all takes space. And so it can't be a small little thing. It automatically grows in size. Then if you want looks to optimize and make the sound less sort of transistor on-off type digital, one is looking to add tubes to that device. Well, that requires additional power supplies for the filaments, and it requires larger transformers. And so what one ends up as a bare minimum for audio interface is having a couple of tubes on the circuit board. One has at least one transformer to power it up. One uses high-grade, discrete power supplies, voltage regulators on that thing. And so the board grows in size. So does the space requirement. So by the time we populated the circuit board with full-size audio-grade components, we also would like to replace a couple of transistors. All this miniaturization is gone. And now think about, we're removing transistors and replacing them with tubes. The sound character of tubes in terms of music is so much more analog. And therefore, if we now went a step further and tried to remove crucial transistors, that for example, that drives the output of the signal with tubes, or add a tube as a driver or as a frequency generator on the master clock side, so its own master clock. And then we tried now to put this board, which is now purposely made for audio, as just a USB interface I'm talking about, just on the side of the DAC. We have a lot of space already used up before we even have the space for the rest of the DAC. If you want looks inside our products, from entry level to sort of our high-end level products, statement level, one thing is going to be very visible and very immediate and obvious. The number of transformers just grows with the performance level. Now, if we increase the number of transformers, then we need even more space. And we don't use switching mode power supplies. Everything is transformer based. So you will see that the space requirements grow tremendously. That's why already by level 4 we outgrown the typical chassis space. We need either 2 chassis or we need even larger chassis, and that's where the problem is. If one starts using USB interface designed adequately for audio purposes, the space requirement becomes a problem. So that's why we can use the USB interface sort of entry-level products, but by the time we go and know this all-out performance statement level, where already even a large chassis and 2 chassis are packed with transformers, we have simply very little space for that. Size and space considerations, they grow as we go in performance level. Now the second point, once we add transformers, full-size proper transformers, not switching mode power supplies, what happens then? Each and every transformer that we have inside the chassis emits electromagnetic interference, EMI, and it has a flux. It emits noise. The transfer of signals is not just sort of electrons movement across the conductor. That's also electromagnetic propagation. The more power supplies and more transformers inside the chassis, the more problematic it becomes to keep the noise floor low. And it's all in one chassis. It's very in conflict. So that's the second point. And third point, one manages to accommodate USB interface inside the DAC chassis. One manages to suppress or keep the noise floor, electromagnetic interference at its minimum, there's still a problem. And that the problem goes back to what I explained earlier. Then one starts to understanding, one starts using different organs again from different donors, interconnected with God knows what. One gets basically a Frankenstein, a Frankenstein, what the Americans would say. Frankenstein in German. So it's a monster. It's not a healthy living organism that can express itself and play music because it's incomplete. One offers only part of the solution and then requires other parts to be donors connected to that device, and then one expects wonders. And that's what basically all people try to do. They try to take donor organs and stitch it all together, create a Frankenstein and expect that that thing will perform like Beethoven and Mozart. So what one needs to do, one needs to think in those terms, in holistic terms. Now, out of this consideration, we graded our DACs and our other products under one umbrella, under one philosophy, that they go together. If you put them all together, it sounds synergistically together as one. We designed a purposeful, a complementary, harmonic matching product, which is our VDT range, Valve Digital Transport. We have USB option on the DAC 1, I have on the DAC 2. One has USB on the basic version of the DAC 3, and then from DAC 3 balance onwards, there's no USB, because we do expect that our DACs are going to be combined with the matching VDT source, which then is designed to complement our DAC range. If one combines our VDT with our DACs, one maximizes the performance of the reproduction of our digital sources.